safe construction practices. In this topic, we are going to learn about some of the important factors to be considered to construct a building resistant to 4 natural hazards like earthquake. A powerful earthquake measuring 6.6 at the Richter scale struck southeastern Iran on 26 December 2003 at 5 am 26 minutes and 52 seconds local time and caused enormous loss of life and near total destruction of physical assets, killing 30,000 people and injured another 30,000. The health and education infrastructure was severely damaged and over 85% house collapsed. A super cyclone slammed the state of Orissa on October 29, 1999, with a wind speed of 270 to 300 km per hour, accompanied by torrential rains ranging from 4,000 mm to 867 mm continuously for 3 days. Over 7 lakh buildings were completely damaged and 13 lakh buildings were partially damaged. The cost of natural disaster to lives, property, livelihood, and infrastructure have skyrocketed in last few decades. As the world's population has grown and people have started residing in areas that are vulnerable to natural hazards. The most successful way to mitigate loss of life and property is to construct buildings that are disaster resistant. This chapter outlines some of the structural safety measures that need to be taken up for constructing disaster resistant buildings. Earthquakes. On December 23, 1972, a series of earthquakes shook the Central American nation of Nicaragua. The largest earthquake registered 6.2 on the Richter scale. The earthquake epicenter was located precisely at the capital city of Managua. The earthquake resulted in the destruction of the heavily populated central zone and damage to a total area of about 27 square kilometers, 10 square miles. Subsequent fires blazed throughout the city, compounding the damages. In the wake of the disaster, at least 8,000 of Managua's total population of 430,000 had died. 20,000 were injured. Over 260,000 had fled the city. 50% of the employed were jobless and 70% were left temporarily home. At least 10% of the nation's industrial capacity, 50% of commercial property, and 70% of government facilities were rendered inoperative. Overall, the damage estimated in US dollars was $845 million. Ground movements. The ground movements caused by earthquakes can have several types of damaging effects. Some of the major effects are ground shaking, that is, back and forth motion of the ground, caused by the passing vibratory waves through the ground. Soil failures, such as liquefaction and landslides, caused by shaking, surface fault ruptures, such as cracks, vertical shifts, etc. Tidal waves, that is tsunamis, that is large waves on the surface of bodies of water that can cause major damage to shoreline areas. Effect on buildings. As the vibration and waves continue to move through the earth, buildings on the earth's surface are set in motion. Each building responds differently depending on its construction. When the waves strike, the earth begins to move backward and forward along the same line. The lower part of a building on the earth's surface immediately moves with the earth. The upper portion, however, initially remains at rest. Thus, the building is stretched out of shape. Gradually, the upper portion tries to catch up with the bottom. But as it does so, the earth moves in the other direction, causing a whiplash effect. The vibration can cause structural failure in the building itself or to an adjacent building having different response characteristics. Taller buildings also tend to shake longer than short buildings, which can make them relatively more susceptible to damage. Protection measures. The primary objective of earthquake-resistant design is to prevent collapse during earthquakes, thus minimizing the risk of death or injury to people in or around the buildings. There are certain features which, if taken into consideration at the stage of architectural planning and structural design of buildings, their performance during earthquakes will be appreciably improved. Some of these are stated below. Building configuration. The building should have a simple rectangular plan. Long walls should be supported by reinforced concrete columns as shown on the right side. Large buildings having plans with shapes like T, L, U and X should be preferably be separated into rectangular blocks by providing gaps in between. Foundation. Buildings which are structurally strong to withstand earthquakes sometimes fail due to inadequate foundation design. Tittling, cracking and failure of structure may result from soil liquefaction. Soil liquefaction refers to transformation of soil from a solid state to a liquid state as a consequence of increased pressure. Depending on the type of soil condition, the depth of the foundation has to be decided. Control on openings in walls. Door and window openings in walls should preferably be small and more centrally located. Too many or large openings will make the wall vulnerable to collapse during earthquakes. The location of opening should not be too close to the edge of the wall. Reinforced concrete bands in masonry buildings. For integrating the walls of an enclosure to perform together like a rigid box, reinforced concrete bands are provided which run continuously on all external and internal walls, including fixed partition walls. One or more of the following bands may be necessary in building: plinth band, lintel band, roof band, and gable band are names used for the band depending on the level of the building where the band is provided. Vertical reinforcement. Vertical reinforcement should be provided at corners and junction of walls. It shall be passing through the lintel bands and floor slabs or floor level bands in all stories. Earthquake doesn't kill people. It is the badly designed buildings that kill the people. So to prevent an earthquake hazard from becoming a disaster, a building should be properly designed, incorporating the earthquake-resistant design features into it. Summary. A powerful earthquake measuring 6.6 at the Richter scale struck southeastern Iran on 26 December 2003 at 5 am 26 minutes 52 seconds. A supercyclone slammed the state of Orissa on October 29 in 1999. On December 23, 1972, a series of earthquakes shook the Central American nation of Nicaragua. The largest earthquake registered 6.2 on the Richter scale. That is all in this topic. Take care, keep learning.